Good morning or evening, everyone. My name is Ritika Tandon, and I'm a Senior Solutions Engineering Manager here at Akamai.
And I'm Pavel Despot, a Principal Solutions Engineer based in Cambridge. As those of you who read the session description already know, organizations can generally exceed their cloud budget by 23%, but there are ways to avoid it.
And for those of you who already use the cloud, this idea of infinitely scaling in the cloud is actually hurting your budget. But there is a more efficient and cost effective way to achieve that same scale.
Thank you for joining us, and today we're going to share a few architectural examples of how you can continue your cloud migration, but without a lot of the cost and complexity that can lead to that 23% budget overrun.
In this era of app modernization or digital transformation, nearly all enterprises have a cloud strategy. However, nearly 93% of enterprises have a multi cloud strategy. Moreover, enterprises employ 3.4 clouds on average between actual use and experimentation. And it's not just about multi cloud, everything is multi platform as well. We no longer think of our infrastructure as just a collection of virtual machines. There is a healthy mix of containers and increasingly serverless that allows us to execute, say, functions as a service or even APIs as a service. So, what is causing this shift in how we deploy our applications in the cloud? The cloud does make some very big promises. It promises higher productivity, where developers or application architects can instantly deploy any of those multi platform resources on demand and at scale. It promises efficiency through improved business processes that leads to greater collaboration and faster execution. It promises lower fixed IT costs and no IT maintenance overhead, and deploying our applications in various regions in the cloud can actually give you better uptime and minimize your risk. All this without breaking your bank. That is the promise. However, there is an anticipated increase in spend on the cloud of 47% for next year. Despite the promise, then, why is it so expensive and prohibitive for organizations to fully adopt the cloud? As you and your end users' demands grow, so does your cloud strategy. More often than not, the multi cloud chooses you. You realize that no single CSP executes well on every aspect of your requirements. You may start off with one cloud provider, realize that it does not give you everything you need and how you need it, so you start looking at alternatives. And before you know it, you re platform a bunch of functionality on this other cloud, and now you're left with a multi cloud. Or your company might go through a merger and acquisition, and the multi cloud, which might not have been what you started with, is what you're forced to use now. This increase in the cloud infrastructure ends up adding complexity. You lose visibility over your data and you lose control over that data. And it's not just about the number of clouds, it's really the cost that you incur to maintain those clouds. And the biggest hurdle of them all is this idea of shared responsibility, where no CSP manages the overall application availability, performance, and security. Each CSP only looks after their own front door. So the cloud automatically becomes both complex and expensive to deploy, to maintain, and to scale. But what if there is a CSP agnostic solution that can help you execute workloads that you traditionally performed in the cloud away from the cloud, all while addressing the complexity and the cost? Let's take a look at how security gets implemented and impacted in the cloud and how we can address those complexity and cost challenges that are associated with it. Broadly speaking, an organization needs to protect its consumers, its employees, and its infrastructure. Because exploitation of any of those entities can lead to data theft, it can lead to cyber espionage, and even denial of service. It's a simple case of following the money. The assets or the data that your attackers get their hands on is extremely valuable and lucrative to them. Therefore, the attacks are never carried out in isolation. They're always multi-pronged or multi-vector, and it's an ever-moving target. It is best for organizations to work with the assumption that the attackers will find a way in to ensure that this game of security whack-a-mole with you continues. And that ends up making this a perennial challenge. A study in 2019 revealed that the cybercrime industry revenue worldwide was a whooping 1.5 trillion US dollars, which is only slightly greater than the GDP of Australia. Cybercrime is a full-fledged industry, and it's run by budding entrepreneurs. They provide services that are rated on the dark web like you and I would rate restaurants on Yelp. It becomes even more critical then for organizations to curb these criminal activities and these criminals and stay a step ahead of them to ensure that money from our pockets does not go into theirs. The big question is how. Let's take a very simple example of the Akamai marketing site, a site that we will refer to throughout the course of this presentation. And let's assume that it has some very fundamental components. The application is hosted on virtual machines. The static content is in a static bucket, and dynamic logic, like the login, is written as a microservice. A high availability setup would look something like this. You have multiple CSPs with multiple regions and availability zones within which you've deployed a multi-platform application. Given that Akamai is a SaaS provider, it needs to comply with any security and compliance regulations that are set by the industry. So the first thing the marketing team does is add on a web application firewall. And we add this web application firewall across all these different CSPs that can defend against the most common application attack vectors. But the marketing team realizes that bots are now wreaking havoc. They realize that their site metrics are getting skewed, as is their SEO ranking. So we add controls to identify these bots and either block them by putting the IPs in your ACLs, or we apply more sophisticated management controls. And given that this is a marketing site, there are a whole lot of third-party integrations that are all driven by APIs. So now we need to add controls to mitigate API-related threats by specifically looking at, say, authentication and incorrect incoming parameters in the request, which is actually the most commonly exploited vulnerability in APIs. And last but not the least, we add visibility, because the data that is generated is really critical to the marketing and security teams to both identify suspicious patterns and take appropriate action to ward off any potential threats. At this point, with all these different controls, the marketing side has a defense in depth strategy with controls that are all layered, and that is really good security practice. But what you end up getting are multiple secure clouds, which is a decentralized approach to security and is inherently both complex and prone to incidents. A study conducted by Sophos revealed that 70% of the respondents suffered a breach. 96% of the organizations were most concerned about their security posture. However, what is really interesting is that 73% of the respondents reported twice as many incidents on the cloud, or multi-cloud, than on a single cloud setup. And 66% of those reported that cloud configuration or misconfiguration, rather, was the number one cause. So, what makes the multi cloud more vulnerable? What makes cloud misconfiguration the number one cause? First, there is the issue of visibility. There is a lack of visibility. In order to achieve your security level objectives, you have to understand the complexity of your infrastructure, and you have to understand the components that build up that infrastructure and how they interact with each other and how users interact with them. And then you need security tools that understand the infrastructure in which they've been placed. Because without that visibility, it is absolutely impossible for you to enforce consistent policies, detect vulnerabilities, and react quickly to any abnormal behavior. Then there is the issue of consistency or lack thereof. Your adversary's primary goal is to find and exploit the weakest links in your organization's attack surface. And the adoption of the multi cloud exponentially increases that attack surface and opens up multiple doors for your attackers to reach you. In order to lock those doors and eliminate those weak links, you need to apply consistent security controls across these different CSPs, even when the infrastructure is in a constant state of flux. But that's just the tip of the iceberg. There's the overhead of maintenance. Each set of controls requires configuring, making it prone to errors. And you have to maintain each of these security controls separately and then monitor them individually to take action. Because your logs get generated in different systems. Say they get generated as shards or partitions, and your team has to look at two different systems and two different formats to really make those logs actionable and glean valuable insights from them. And because security is a shared responsibility, there is the problem of getting the right personnel. It is you who needs to protect your applications in the cloud and have to therefore build a team of security experts that is both an expensive undertaking and security experts are really hard to come by. But what if there is a better, less complex, more cost effective approach? What if there is that CSP agnostic approach that is centralized and gives you consistent controls, it gives you greater visibility, instant scale, has only one set of configurations and rule sets for you to maintain that prevents that entire issue of misconfiguration, and you get a dedicated team of experts to ensure that your security posture is always upright. And that's when you look at the edge as that centralized security platform. You can put protection for denial of service on the application layer, the network layer, as well as for DNS. You can protect against common attack vectors like SQL injections or cross-site scripting through the web application firewall. You can ward off mage cart-like attacks using script protection and even take advanced and conditional actions for bot traffic and look at your API authentication and incorrect parameters in the incoming request to ensure that any API vulnerabilities are not exploited. The edge also gives you access to the cloud security intelligence platform that can inform you of the reputation of an IP and allow you to take proactive action before that IP accesses any part of your application and leave alone reach close to your infrastructure. All these controls are then tuned by experts. And most importantly, you get real time data streams that arm you with that critical visibility to protect your users, your employees, and your infrastructure. The overall security and visibility of your applications can be maintained within one single edge platform, regardless of the underlying CSP. Moving security to the edge can actually augment and support your cloud workloads. It gives you greater visibility because remember, you can't really secure what you can't see. It gives you consistent security so that it can keep up with your underlying infrastructure, which is constantly changing and evolving. And it can save you cost by helping you or allowing you to manage only one set of controls and significantly reduce that maintenance overhead. It's really important to note that multiple secure clouds, which is a decentralized system to security, is not the same as secure multi-cloud, which is a centralized system of security and is potentially a better approach for you and your organization.
It's hard to follow security, and especially when talking about load balancing, mostly because security has been extremely top of mind recently, given some of the very public attacks and the crypto attacks and some of the DDoS attacks that we've been seeing lately. Traffic management issues, on the other hand, generally manifest themselves in terms of slowness, and oftentimes it's difficult to even know that you're having a problem. Aside from that, though, it is very similar to the security effort in that at the end of the day, both of them are dealing with the problem availability, albeit from different reasons. And both of them need to be designed in from the very beginning. Generally, when we look at a lot of attempts at traffic management these days, especially in the era of microservices, we see a lot of ineffective or completely absent approaches. The result is each microservice or each part of the application really just does whatever they like without a centralized way of controlling things. And much like this crowded intersection, the result is A, underused resources. You have very empty roads that are not being used, just like you have compute that you're paying for that you're not using, and other parts of your infrastructure, like the center there, that's overloaded, and that's impacting the availability of the traffic system entirely. On the other hand, run into a situation where you're just starting to layer different approaches on to different services. In the end, what that ends up doing is certainly increasing complexity, but also increasing the cost of managing and running each of these things. And ultimately, if we look back to what we just said a couple slides ago, the impact, or the reason we're doing all this, is to improve our availability. This complexity in this approach does the exact opposite. And even when we don't have those availability issues, what's going to happen is it's going to slow our response because each hop takes processing time. So what can we do to prevent that? Well, really it comes down to simplicity. And we can think of simplicity in really three ways. One is something we call proxy fatigue. And proxy in this instance can mean maybe an HA proxy, Nginx, a function, but it's another layer of processing that you have to do to implement to do some traffic management or failover. The reason we have to do that is number two, in that we often get requests to implement features, implement functionality. And the first thing that we're usually told when we get these features is, hey, I need it by X. So what we end up doing is we end up sacrificing what the site reliability engineering people call initial velocity for sustained velocity. We all know it as, hey, get it done, and then you end up with a permanent solution, which we all know, or a temporary solution, which we all know is one of the most permanent types. And at the end, it's a bad permanent solution because, as we'll see in a moment, what you really want to do for load balancing is load balance away from the destinations you're trying to load balance across. You're not going to drive to the mall to find out that it's closed. You're going to figure out beforehand and then try to pick a different mall. So for our example here, let's use the website that we've been talking about this entire time. And let's go back to the architectural example, but we'll dig in a little bit more deeply into the pieces, not too much. So we'll start, of course, as Ritika said, with our web servers. And in this case, we've said we're going to deploy VMs. That's less important, but the important part is that for availability, we are going to deploy 2 pairs in 2 availability zones with load balancers, load balancing the traffic between the 2 locations. And we have some layer 7 routing, as Ritika mentioned, to go to our static content. Very straightforward setup. So from here, let us assume that we have to deploy a chatbot service. As for those of you that have actually looked at the site, our site does indeed have one. And a way you would deploy that is by using your favorite technology and deploying one of those microservices into each availability zone. So that's no problem. Where we go from there, though, is a bit of a problem, as we realize that our chatbot has to be stateful. This is an instance where we just can't route to either one of them. So the way we decide to fix that is that we add a proxy or function, basically some function that will look at maybe the cookie or in some way direct a request to the right chatbot if it hasn't been sent to the right one initially. Back to our mall example. Well, now, again, the big promise of the cloud is that we can always add another region, and especially recently, we might be asked to do this for GDPR or other reasons, or just localization. And let's say in our example, we deploy our Akamai marketing site into a region in Germany. Thankfully, like we said with the cloud, everything's easy. I can deploy my chatbot, my web servers, and my static bucket quickly without having to deploy any physical hardware. But what we have now is a different problem. And whereas before, we had to reroute and redirect some of that traffic for the chatbot, now we have to do the same thing, but across regions. So there are a few different ways to do it. We often see people issue redirects, or maybe you try to synchronize state on the back end, but then you get into all sort of data sovereignty issues. Ultimately, whichever decision you go, you end up with something like this that is now far more complex than just these couple of requirements suggested we'd have to get. So what can we do as a result? So instead of taking the previous approach and duplicating each one of those functions and multiple proxies in each region to try to remediate the poor routing? What if we could eliminate all those, eliminate the poor routing to begin with, and just choose the correct destination from the beginning and do so in a single unified layer? How would we do that? Well, as those of you that might be using Akamai today know, all that functionality already exists with any of the CDN or Kona products that you might be using. So we start with, of course, DNS. And DNS in this case is going to solve the issue that we just discussed about where does it go? Does it go to Europe? Does it go to our other data center? And that was the problem we were trying to solve initially. Doing so eliminates that extra layer that we saw before of getting it back to the right place. We also saw, though, in the previous example that we had layer 7 routing. We routed different paths to different locations. Well, as it turns out, we can implement that same matching and that same logic functionality at the edge without having to duplicate individual instances in region 1, region 2, so on and so forth. Of course, the last piece, since we're going to be now managing all of our health checks from a centralized location, is the health check itself. And again, those of you who are familiar with this know that those same health checks are going to be monitoring all these endpoints. The idea in doing this, of course, is to reduce our costs. The way we're doing that is, if you'll notice in that last architecture, we had a lot fewer functions to implement. That not only saves our costs, but 2, it actually reduces our effort. Each one of those functions, machine proxies, whatever you've implemented in, need to be maintained. They need to be monitored. They need to be upgraded. So by reducing the number of those elements that we have in our design, we reduce that maintenance effort. And finally, by reducing the presence of these additional network elements, we're ultimately going to improve the resilience of our application. Bringing it back to what we started with, it's really about simplicity. And as far as load balancing goes, moving that logic out to the edge is how we can achieve that simplicity and, as a result, the scale and the simplified management. It gives us that one unified, unlimitedly scaled ability where we don't have to change for each environment. Now, so far we've spoken a lot about security and load balancing, focused a lot about us, those of us who have to maintain and secure these environments. But on our final topic, we decided to spend a little bit of time talking about our users. We're, after all, securing the data for them. It's their data. We are making sure that the service is up and available and usable for them. So we should also look at one of the biggest factors in their perception of our service, and that's performance. And one of the biggest factors in performance, of course, is content. We'll focus today on how we can help with specifically 3 pieces of content: long tail static, dynamic, and images. And as it turns out, there are very efficient ways to help with the optimization of that content at the edge. And for any of you rowers listening, you probably all know that the best way to get one of these things moving is to have everyone in the boat synchronized and sure about what they're doing and when. And in the same way, that's what we're suggesting about synchronizing some of these functions and some of these optimizations out over at the edge. What instead we're seeing happen today is that the way where people are dealing with these problems of user performance and these different content problems is just by scaling and adding bigger and more instances. Now, traditionally, horizontally and vertically scaling works, but that was the whole idea of the cloud. It's what we did. We added more regions until we ended up with sprawl, as evidenced by the litany of solutions out there to help manage all of our cloud sprawl. But the question is, are we really scaling the right way? Is this more brute force-ish approach correct? Because at the end of the day, this just sprawl, this proliferation of compute in multiple locations leads to, like we said, duplicate functionality. So if I have to copy my buckets in multiple geographic locations, I'm just duplicating the data I'm storing on my cloud provider. It is going to take more effort to monitor and log and troubleshoot, just like with our security and with our load balancing. And for anyone who's ever tried to debug these very distributed, multi-tiered things, they know that it is by no means a simple thing. And that is exactly where all this cost and compute and management really comes from. So instead of trying to deal with these content problems by sprawl, let's look at it in a homogeneous way that works across CSPs. And much like what we spoke about with the other edge features or the edge architecture, reduce that complexity, because that's what's going to help our cost on both the compute and the management. And of course, we'll start first with our static content. Akamai having started out as a CDN over 20 years ago, it's a good place to start. And remember again that the idea of delivering from the edge is desirable for two reasons. One, it decreases our cost, because when you deliver from the edge, that is cost that you are not paying egress to your cloud provider. The other one is user experience. By the content being close, it loads faster, the user is happier. Long tail and live linear content, however, has been more challenging than other types because caching is based on popularity. As a result, less popular content has resulted in less offload, which just simply means that we have to retrieve the content from the origin more often. And every time we do that, there's an egress cost. So what we've done instead is taken part of the edge, because traditionally we just talk about the edge near the user and being one hop away from all the users in the internet. But remember, Akamai is also the edge near the data center. And that's the edge that we can essentially use as a private cache tier for some of this content traditionally has been more challenging to serve with other caching methods. As a result, that's going to, as we mentioned, improve our performance for our users, because that's what we're trying to do in the title of the section. But it's also going to do things like decrease the number of global buckets that we may have deployed to help with that performance issue. It's going to decrease the number of bytes from the buckets that you do have remaining, because we're offloading that to the edge. And that's where the cost aspect comes from. It also helps simplify management, because the second you can decrease it to one bucket, you can get away from those annoying operational things like having to sync up between two buckets and making sure your content is fresh and managing the purge. Now, of course, we spoke about static content. The other piece is dynamic. I like to think of it more as non-cacheable. But dynamic content or non-cacheable content simply means that the requests themselves have to go from the user to the CDN, through the CDN to the origin. So they always incur some cost, some ingress and egress cost. And those of you familiar with Akamai, again, are probably familiar with some of the things that we do to decrease the number of bytes and compress that. But ultimately, we can't bring it down to zero. So the other way we can affect cost is with agreements that we have with some of the cloud providers right now, GCP, to decrease the cost for customers that are coming from Akamai to the cloud providers. And again, particularly useful for dynamic content because the offload optimizations aren't possible, because we do have to communicate with the endpoints for this type of content.
Now that we've looked at traditional static, long tail content, as well as some traditional dynamic content, let's look at how we can use the edge to do more. Remember the example of that marketing site? It does have a lot of images, and it has a hero image of a very high quality. And all those images and that hero image is being accessed by a wide array of users through a wide array of devices. And all those images need to be optimized for all those devices. You could use the edge for image manipulation on the fly, closer to where your images and your requests originate. Take Ubisoft, for example. They use the Edge Image Manager solution and were able to recoup 20% of their development time that they then employed towards building out more business critical functionality and making the image transformation process more efficient and better performing. They were not only able to achieve consistent load times, but also that consistent user experience that Pavel alluded to. And now that we've talked about images as well, I want to draw your attention to some more logic, some more dynamic logic than you can offload on the edge. With the advent of regulations like GDPR and CCPA, compliance is top of mind for organizations because in compliance actually attracts heavy fines, but that's not all. There is also the overhead where every incoming request must be checked for consent. You can think of the edge as the platform that captures that user consent, and you can then take appropriate action instead of going back all the way to your CSP instance, which costs both money and adds latency. In general, running serverless on the edge, running functions or microservices on the edge can actually help you achieve economies of scale. Because if you run the same functions across a distributed set of cloud service providers, you cannot get the same volume. Remember, this works exactly like a mobile plan. The more data you buy, the lesser you pay. You can therefore reap the benefits of higher volume and instant scale by consolidating all your functions on the edge. To wrap this section up, by bringing your experience optimization processes closer to your end users, you can in fact optimize the performance and compute of your applications for both complexity and for cost.
The edge isn't just an extension of the cloud, but the ideal location to deploy some functionality that's critical to how we build modern applications today. And the cloud certainly does fulfill a lot of those big promises. It's absolutely true. I have never spoken to somebody who misses racking and cabling machines before they can deploy their application. But the cloud, I think, was just a first step in a bigger evolution of where we as application developers and architects can deploy some of the logic that makes this application up. And as architects, devs, DevOps, whatever we call ourselves these days, we need to consider all of these options. And of course, cost management is a huge piece of it, as we've spoken about. But another piece that goes hand in hand with the cost management is complexity, because there, what we're going to gain from is cost savings, certainly on the operational side, but also fewer of those, hey, my application is down, hey, my application's been compromised, hey, it doesn't work as quickly as we need it to. We hope that through this presentation, we've helped you think of some new architectures and some new ways to go about securing and improving the availability of your application. Thank you all for attending. This is Pavel Despot, and have a great rest of your day.